For the next section, we have Adarsh A.K. Kumar. He will take a session on autoscaling beyond CPU and memory. Adarsh A.K. Kumar is a lead product engineer at Rapido. He will dive into the horizontal pod autoscaler works in Kubernetes and discuss using Prometheus Adapter and KEDA for Kafka Lag-based autoscaling. Let's give a warm welcome to Adarsh A. Kumar.
Cool. Hi, good afternoon. Am I audible? Cool. Cool. My name is Adarsh. I lead the infrastructure platform team at Rapido. And today we are going to talk about autoscaling beyond CPU and memory. So, how many of you do autoscaling in production today? How many of you don't do autoscaling in production today? Sorry, that's what I should have asked. Don't do. Okay, cool. And have anyone used tools like Prometheus Adapter, KEDA? Cool. Cool. So let's get started. Why do we need autoscaling in first place? Anyone? Right. But we need to make the cloud providers rich as well, right? That's the main reason for using autoscaling. But on a serious note, your answer is right. See, our traffic keep changing throughout the day. The pattern keep changing throughout the day. For example, at Rapido, like any ride-hailing application for that matter, morning you all are going to office. So morning there will be a spike in traffic. Similarly, in the evening coming back from office, there will be a spike in traffic during that time as well, right? Saturdays, obviously, Monday, it's like Saturday mornings, there will be less traffic because after Friday's party, we'll be still sleeping. But then evening again, we'll go out for a party. So evening again, your traffic will increase. So the pattern of traffic keep changing. Now, how do we ensure our system scale according to that? One option is manually sit and do that, but then it's not fun, right? And we might make mistake, and we don't want any kind of toil. So to ensure that our systems are performant with the change in traffic pattern, we need autoscaling, and basically that is cost effective as well. One option is I know morning and evening there will be a spike. I could say I need 10 pods of my application. I could throughout the day run 10 pods, but then that is waste of money. So cost effectiveness is one other reason of why we need autoscaling. Cool. Now in Kubernetes, when we talk about autoscaling, we can talk we can talk about two things. One is pod autoscaling, any kind of autoscaling for that matter, right? If you take, you can do, or any kind of scaling, not autoscaling, you can do it in two ways. One is vertically scaling, the other is horizontally scaling. Horizontally scaling means increasing the number of instances and replicas. Vertically scaling is throwing more resource to that single box or single instance. That is vertical and horizontal scaling. Now in Kubernetes, we have both. There is HPA, which is horizontal pod autoscaling. There is VPA, which is adding more resource requests based on certain metrics, right? So vertically increasing the size of an individual pod or a set of pods for that matter, that is VPA. Of course, when the pods start increasing in size horizontally and vertically, the underlying node also should start scaling. That is where we have node autoscaling. And we have tools like cluster autoscaler from Kubernetes community itself and Carpenter from the AWS community, which support that. We'll Okay, today we'll be focusing mostly, or rather we are focusing only on HPA, and let's get to that. So cool. So what does HPA do? How many of you use HPA in production? Do anyone want to take a shot what HPA is? Right. So based on the increase in demand or traffic, it will basically go ahead and increase the number of pods, right? And how does it do that? There is one precondition. It only support workloads that implement the scale sub-resource. For example, you run a command, you can manually scale deployment by executing a command kubectl scale deployment and the deployment name and hyphen replicas and the number of replicas. That scale there means the type deployment, that's a workload type that implement a sub resource type of scale. So any workload type that support this sub resource of scale can be autoscale using HPA. Example is stateful set and deployment, but we can never autoscale a daemon set, for example. First of all, it is meaningless and it doesn't have a scale sub resource. Cool. On a high level, am I audible? No? Cool. On a on a high level, right, what happens with HPA is, you can see the HPA component there, right? What it does is it talks to an metrics API. We'll tell where this metric API comes from, but end of the day, the HPA component talks to a metric API and then call the scale command on the deployment or any workload. And that will go ahead and increase the number of pods. That's what basically HPA does. In a moment, we'll see the definition of HPA and we'll see a demo as well. Cool. So this is the desired state of the HPA that we are going to define here. This is fairly straightforward. We'll quickly look at it. This part tell what is the workload type that I'm targeting. It's a deployment of type PHP Apache, just a name of a deployment. The bounds within which to autoscale. What is the minimum number of pods? What should be the maximum number of pods? And finally, we are talking about a metric. This is an important part. We'll get to it. So here we are autoscaling based on CPU utilization. We are telling at 50% we'll autoscale. Also, I am calling your attention to that type there, resource. We'll come to that in a moment. So in that previous image, here we saw that HPA scales based on a metric API. Right. What are the different metric APIs that is available? By default, the CPU and memory-based autoscaling we do. That is resource metric API, that is metrics.kats.io. That is implemented by something called metric server. We'll see a small demo and then we look at the other two types of metric API. Cool. Visible in the back? Okay, so I have a deployment here called PHP Apache, right? And I'll quickly show that. It have a resource request of 200 millicore. We are going to autoscale this. What we're telling is, let's autoscale this deployment. This is going to create the HPA component for us. This is an imperative command that I'll be running, which will generate the spec that we saw. We'll never do this in production, by the way. So this is just a demo. So CPU percentage, I'm telling at 50% we'll start scaling. And I want my bounds to be maybe 1 and 3. Now what happened is, if I do kget HPA, I can see my HPA object gets created here. I'll quickly open that up. Similar to what we saw already, right? Like we have the metrics type specified here of type resource. This comes from metric server. This metric comes from metric server. This is the metrics.kats.io that we saw. And it's on utilization. So 50% of whatever request that we have set on the deployment, which was 200 millicore. When it reaches 50%, it will start autoscaling. Let's try to generate some load. So I have visible, right? Cool. So I have a command here that is going to generate some load. Basically, just if you see here, this is the critical part of it, nothing else. It is going to keep calling that in wget continuously in an endless while loop with a small sleep in between. So I'll call this. So you can see on the top the HPA, and you can see the number of pods that I'm running. So yeah, it will start putting load on my deployment object. Let's confirm that. I can see the wget calls coming in. Let's describe the HPA object. you can see the utilization and went to 224%. It's already shot up above the 50% mark that we have set. And now if you go and describe it again, it have now increased the number of replicas. This is how a basic HPA works with CPU based resources, right? This is something that is we have seen usually. Now we'll stop this part. Okay, yeah, while at it, I want to just show one more thing. If you see here, this last condition, right, scaling limited. Scaling limited, while using any kind of auto scaling, one thing we have to do is we need to have good monitoring on that to understand what basically happens. Otherwise, cloud provider will become rich, or our performance won't become as expected, right? What we are expecting. In this case, scaling limited have become true because the max number of the bounds, right, minimum and maximum, max have set is 3, and if you see here already 3 replicas are running. But my traffic, if it keep increasing, that 3 might be misconfigured or there is some unusual traffic coming. So we need to have good monitoring setup in place to ensure that whenever HPA maxes out, we get an alert and we respond to that. Cool. That was quickly what I wanted to talk about. This is normal that we have seen. Next is custom metrics based HPA. So the resource metrics is nothing but CPU and memory based scaling. Custom metrics means any other metric. So the resource metrics remain same. The names of that, all of this remain same across clusters. It wouldn't change from one cluster to another. Whereas custom metrics are arbitrary metrics that are generated or that describe any of the object within our Kubernetes cluster. Any object, when I say only like pod is one object that is supported. Another one is like you can target any other object, like for example, ingress in this case. If you have an ingress object and there is somewhere you are capturing a metric which describes that ingress object, it need not come from your ingress controller or anything, but somewhere it is getting generated. But for example, requests per second or packets per second that is handled by a pod, we can auto scale on those. Now, where does this custom metrics come from? Like we said, metric server is what is handling resource metrics. So by default, Kubernetes API server doesn't give any of this metrics API, be it a resource metric, custom metric, external metric, right? None of this is by default given by Kubernetes API server. There are extension layers. Kubernetes is very extensible. So there is an API aggregation layer with which we can extend your Kubernetes API server or the cluster to support additional capabilities. In this case, you can use Prometheus Adapter. So what Prometheus Adapter does is similar to what we saw previously, right? HPA will look for metrics somewhere. Now HPA will ideally ask API server, do you have any idea about this metric? When we deploy Kubernetes or the Prometheus Adapter, what happens is it goes ahead and registers with your API server telling, dude, I'm going to give you everything with respect to custom.metrics.k8s.io. So that if I'm making a call for that, it will get proxied to Prometheus Adapter. And Prometheus Adapter, end of the day, talk to Prometheus. You all have a Prometheus deployment in production, I'm assuming. So we'll have to leverage that. But this is how a configuration would look like if you want to configure Prometheus Adapter to make this whole scaling work. And like there are various parts to it. Like first part is with respect to discovering the time series. Second is associating that metric to a pod or any other Kubernetes object, because we said it is with respect to anything running inside your Kubernetes cluster. There is another type called external metrics. So not necessarily all the cases, but if you want to associate to something within your pod, this is where that happens. How do you want to name that metric when your metric API returns that? Finally, the actual query that you are going to fire to Prometheus. Don't worry about the details of this. And like I said, we talked about resource metric, we talked about custom metric. Custom metric is basically metrics of objects within your cluster. External metrics is anything that is outside your cluster. One example is if you're running Kafka in VMs outside your Kubernetes cluster, and based on the lag that gets generated on a Kafka consumer group, you want to scale the consumer, right? I'm deploying my Kafka consumer as a deployment. As and when more messages are coming into my Kafka topic, I want to auto scale. So that is one example of using external metrics. Now we'll see a demo with external metrics. So I want to quickly introduce my demo setup. I didn't want to set up Kafka and like the Kafka monitoring, etc. in my kind cluster. This cluster is running in my local using kind. So what I did is I just deployed a fake exporter. It's a simple code that I've written. I'll quickly show that. All it does is it defines a metric called Kafka.lag, Kafka underscore lag. It takes two labels. Everyone on a high level understand Prometheus metrics, the form of that, right? There will be a value, there will be a metric, something that we are measuring, some associated metadata which defines that. Here what we are measuring is Kafka lag, and Kafka lag in general are related to a topic and a consumer group. And I've written some dummy APIs like increment, decrement, etc., which will go ahead and increment and decrement this value. Ideally, there will be an exporter which will be talking to Kafka and figuring out what is the lag, but here I'm faking the whole thing. And then what else do I have? I have deployed Prometheus Adapter, the whatever we just talked about, custom metrics with respect to exposing. So basically, Prometheus metrics getting exposed as a metrics API. In this case, an external metrics API is what I've configured here. It's quite convoluted, right? Not at all easy to comprehend. This is one example I'm talking about, like just Kafka lag in one case. Like that, we'll have 100 metrics to autoscale on. Not a very easy thing to do, but yes, this is what we have now. I'll just show one thing, KGet API services. So when I deployed metric server, like I said, they'll go and register with your API server as provider for that particular API. When I deployed a metric server, if you see there, it went ahead and created a API service registration. What it does is it will tell, hey, for v1 beta1.metrics.kedas.io, I'm going to be the provider. Similarly, I deployed Prometheus Adapter. It went ahead and tell, for Prometheus Adapter, just one thing I'm telling that for all of these APIs, there can only be one provider at a time. We'll see an example of that as well in a minute. So when I deployed Prometheus Adapter, it went ahead and registered as the provider of external metrics. So we saw both of that, and there is a service monitor which is used to scrape that metrics from the fake exporter. I'm having Prometheus operator running, which is getting all the metrics. So yeah, this is how the metrics would look like. So I have Kafka lag metric, and I have my Kafka lag metric. You can see those labels that we talked about. There is some group, and random topic name and all that gets added to it, and some value. We can try incrementing and decrementing that. So it get accordingly decremented. So this is my whole demo setup. Now, so there is this command, okay, kubectl get row. You can directly hit any Kubernetes API using kubectl. So end of the day, kubectl is a client, your API server is a server. It's purely a REST API based conversation that happens there. You can use this row to directly hit an API instead of telling get pods, etc. Now we'll quickly see here. Our custom metrics is already registered. So in a normal Kubernetes cluster, when you run this command, it will tell, I don't know what external metrics is unless you have external, there is a provider for this external metric setup. So here, whatever Kafka lag based thing, we are able to see that, right? Cool. Now what I'll do is the HPA object that we previously saw, right? I'm going to patch that. I'm ignore about this command. I'll show what is the outcome of this that will make you understand. But I'm adding one additional metrics to that HPA object. I'm patching the HPA object by adding one more metric of type external. And then I'm going to run that command. I do kget HPA -o equal to YAML. Cool. So now if you see here, I can see two metrics. One is of type resource which is coming from metric server. The other is the external metric that we are autoscaling on, which is again served by Prometheus Adapter. And here I am telling what is the metric type. The metric that we have exposed from there is Kafka Lag, be it in Prometheus or after renaming in Prometheus Adapter, it is called Kafka Lag. So that is a metric name. And then I'm telling how should I match. Now, assume Kafka will be used by multiple services, right? Not every service should autoscale because one service have Kafka Lag. How do I do that is basically I pass in what is the group name. Group will be unique. So if I'm talking to Kafka, I'll tell, hey, my name is Adarsh, I need this information. So that will be based on the group name. So that is the group name I'm passing and the target value based on which I will be autoscaling. So we are back to one replica with our HPA object, right? The CPU component is fine. It is at 0%. The other one is 200 out of 200. So it's at neck to neck. There is no autoscaling. Only if it goes above that, it will start autoscaling because it's value-based one, not resource, not utilization based. What I'll do now is I'll call the increment operator maybe 1 or 2 times. And you can see the target immediately change. It's above your expected value. It's above desired value. We'll try to describe. And immediately it have already increased the number of replica as well because of the reason external metric have gone above the threshold value. Okay, now I have 2 triggers or 2 parameters on which I am autoscaling. What Kubernetes HPA does is it takes the max of individual. Like if the first one tell 2, second one will tell 3, it'll go with 3. It'll take max. That's the only option. There is no way to modify that. We are running out of time. We might have to skip the last demo, I think. Cool. This whole Prometheus based business, right? Like whatever we just saw. It was not that easy if you ask me because Kubernetes is, I'll tell I want a pod of so and so image, so and so type. Like you tell what you want, you get that, right? Declarative. Here I had to do association, discovery, renaming and all that bunch of other stuff. Can we make it any simple, right? That is where KEDA will come into play. It's basically Kubernetes event-driven autoscaling, right? And one important or one exciting thing to know about KEDA is that it supports scaling to 0 pods, which HPA doesn't support. Let's say you are doing some PDF processing. Whenever a request comes, you have to generate a PDF file and send invoice, for example. And you are not getting that request all the time. At night, nobody will come and ask, hey, generate the invoice and send me, right? Very unlikely. But if that is the case, do we still have to run with Kubernetes HPA? You will have to run at least 1 pod. Can we save that? Like that, if you take 100 services, 100 pods will be running. Can we save that cost? We can. That is what KEDA provides. KEDA have something called, if you see, right, based on any events that happen, file get dropped. That's an event. It will autoscale. Also, it is built to activate a deployment. Activation is nothing but scaling a pod from 0 to 1 and 1 to 0. That is activation and deactivation. From then on, whatever KEDA is doing, that is basically it is piggybacking on the normal HPA itself. So what are the features? Autoscaling made simple. Like you don't have to worry about configuring how to query Prometheus and all that stuff. It's event driven. Something happened, you autoscale based on that. You have 50 plus built-in triggers. You can write your own custom scalers as well. And you can scale to 0. Again, something which Kubernetes HPA doesn't provide. We talked about this. On a high level, like how we have HPA object in Kubernetes, in KEDA, what we have is something called scaled object. And this external trigger source, you can consider that as our Kafka cluster in this example. And if you see here, right, one interesting thing in this image, we'll tell what are the different components in KEDA. So 0 to 1 and 1 to 0, that is handled by KEDA. The activation phase or activating the deployment is handled by KEDA. That is taken care by the KEDA controller. And if you see the other side, 1 to n and n to 1, that is taken care by your Kubernetes HPA. So end of the day, we saw metric server, we saw Prometheus Adapter, all these things, right? Internally, KEDA is going to register as an external metric provider, and like HPA object will be generated for you. You create a scaled object, but you'll go ahead and create an HP object. We might have time for a demo, I think. I may take 2 minutes if that's okay. So this is how a scaled object would look like. For example, Kafka-based scaling, that's all we have to do. Like there we had to write query and a bunch of other things, but with Kafka provider. So KEDA directly connects to your Kafka cluster. And for that, there is some authentication, like another object which is used for like authenticating to your Kafka cluster. Similarly, another one is cron-based scaling. Morning 6, increase the number of pods to 10 till evening 8 p.m. You can have cron-based scaling. And like if you still want to do, you have some metrics on which you want to do, that is supported as well. Right, that's basically what this is about. We'll see if we can quickly do a demo. I'll install KEDA, but that will fail. It failed because I said we can only have one provider, right? So I'll have to go first uninstall Prometheus Adapter, because Prometheus Adapter had already registered as external metric provider. I'll install KEDA. I hope it's installed. Okay, there are 3 components that got installed. One is your operator, one is the API server. Like I said, no, KEDA will become your external Metrica API server. And then there is an admission webhook. We'll see an example of that as well. We still have the HP object from our previous example that we ran. So we'll try to create that. Okay, this is again targeting the same PHP Apache deployment. And we are telling based on some Prometheus metrics, similar to what we had before, right? Go ahead and autoscale. I'll quickly apply that. Sorry. But that failed as well. It says denied because there is already an like that object is already managed by another HPA. That deployment is managed by another HPA, which is the HPA we created in the previous example. Now this is done by the admission webhook, the component that we saw, right? So any kind of validation is taken care by admission webhooks. We don't have time to go into details of that. So this basically there are checks and balances in place with that admission webhook to ensure that we don't screw up. So I'll go ahead and delete that HPA component that we have. I went ahead and created the scaled object. Now, in general, for any object, there will be a controller in place which will be ensuring your live state and desired state is getting reconciled. In that diagram, we saw there is a controller. But interestingly, if you see, right, an HP object got created for us. So activation is done by KEDA. Scaling is piggybacking on the normal Kubernetes HPA. If you look at that, 10 seconds, I'm done. If you look at that, 2 metrics are there. One is similar to what we saw, like it's very similar to what we have early, but it was configured in a much easy way, right? It doesn't have the convoluted way of configuring that Prometheus things. So that is all I had with respect to this. If you have any questions, let me know, but I don't know if I have time for questions. Otherwise, we have time. Yeah, if you have any questions, do let me know.
In the interest of time, we can take one question.
Cool. Anyway, I'll be around. We can catch up.
Awesome. Awesome. Thank you, Adarsh. So definitely it was indeed a wonderful session. He did cover on the autoscaling part, HPA, VPA, and the cluster autoscale and KEDA. I'm pretty sure it was definitely helpful for you all. Thank you so much, Adarsh.